Hi there, my name is Dimitris Karlabidis, and in this video, we'll talk or we'll have a first introduction in the absolute value inequalities. So let me begin by properly writing down the title. Absolute value inequalities. Okay, let's begin with a first inquiry. Absolute value of x smaller than 3. Let's try to interpret that. Let's try to translate that in words. Absolute value of x stands for distance. So I need to find the number or numbers, there could be more, the distance of which from 0 is less than 3. So I need to find that number, x, or those numbers, the distance of which from 0, and how did I end up with the distance of which from 0? By the form, by the absolute value. That's what absolute value means, is less than 3. Let me do a number line which might assist me on that. 0 is somewhere in the middle. And since we care about the distance being compared to 3, let's see when is a distance equal to 3. Obviously, it's here, if this is 3, and here, if this is negative 3. So we know that the distance from negative 3 to 0 is 3 units, and at the same time, the distance from 0 to 3 is also 3 units. But I don't want the values of x for which the distance from 0 is 3. I want the values of x for which the distance is less than 3. So if by being here, I have a distance from 0 equal to 3, doesn't that mean that in any of these points won't be my distance from 0 less than 3? Yes, same goes to the left region. So I would have said, as an answer to that, you know what? X should be smaller than 3, and at the same time, X should be greater than negative 3. If I repeat that again with absolute value of X being less than 10, it still means find the values, find numbers, the distance of which from 0 is less than 10 this time. Again, by doing a number line, and since this time I want to compare them with 10, I would have said that, you know what? It's every single number between negative 10 and 10. All these numbers in here. Again, to formalize it using math symbols, I could have said that it's x smaller than 10 and at the same time x greater than negative 10. In general now, absolute value of x smaller than a quantity theta, where theta is a positive number, would mean that x should be smaller than theta, or x, not or, sorry, and it's important to use the proper communication, and x greater than negative theta. I'm going to write that here as well because we will need that. X smaller than theta would have meant smaller than theta and greater than negative theta. And of course, we should always remember that math, when we present something, it's not just about that symbol X. It's about that expression X. So in general, absolute value of an expression is smaller than a number theta, where theta is positive, would have meant that this expression is less than theta, and this expression is greater or equal than negative theta. Let's work out some examples together. Absolute value of x smaller than 5. Obviously, x should be smaller than 5, and x should be greater than negative 5. Another interesting thing in inequalities is that we present, it's not mandatory, but it's better. We communicate the solutions in a better way. We present the solutions on a number line. It's not hard to create a number line, just draw a line, put 0 in the middle, and then based on your solutions, represent them, visualize them on that line. X less than 5. So 5 could be here. Since it's less and not less than or equal, we should have an open circle. Less than 5 means from 5 to the left. So towards that direction. Greater than negative 5, if this is negative 5, we would go towards that direction. And obviously, since the connected word between them was the word and, we can see that this is this shaded region represents our solutions. Absolute value of 3x plus 5 less than, let's say, 11. It's just about the expression inside the absolute value. So 3x plus 5 should be less than 11. And 3x plus 5 should be greater than negative 11. So 3x should be less than 11 minus 5. So 3x should be less than 6, or which means that x should be less than 6 over 3. I'm going to make that less than or equal so that we can see a different symbol in the number line, x smaller or equal than 2. And at the same time, 3x greater or equal than negative 11 minus 5. So 3x greater or equal than negative 16. X should be greater or equal than negative 16 over 3. Let's put these on a number line. 0 somewhere in the middle. Smaller or equal than 2, if we assume that here is 2, since it's equal, this means that it's included as well. So it's shaded circle. So it's from 2 to the left. Greater than negative 16 over 3. 16 over 3 is 5 point something. So again, a shaded circle. But greater or equal than that would mean from here to the right. So this shaded region would have been the answer. Of course, we should always remember that, we should always use the knowledge provided from theory, which means that if for some reason we were given, let's say, this absolute value of x smaller than negative 10, what should we do in that case? If we try to interpret it verbally in words, that would have meant find the number, all numbers for which the distance from 0 is less than something negative. hold on. Absolute value, or means distance, and distance, it's always greater or equal than 0. So how come a distance can be less than something negative? How come something which is by default greater or equal than 0 can be even less than negative? Never. It can simply never happen. So in this case, we would have said no solution to that. Let me write it here as well at the right. Absolute value of x smaller than something negative, no solution. Let's move on with the next type of inequality. And let's begin as well with another inquiry. Absolute value of x greater than 3 this time. In words, this means find the number or numbers, the distance of which from 0 is greater than 3. Okay, I'm going to use another number line to help me on that. Since I want to compare the distances with 0, let's begin, like we did before, from where the distances would have been equal to 0. These would have been the boundaries. The distance between -3 and 0 is 3, and the distance between 0 and 3 is also 3. So if I'm at these places, at 3 and -3, my distance is exactly, from 0 is exactly equal to 3, which means that if I want to get a distance greater than 3, I should be moving either on this region or on this region. You see that in this case, I use the word or. And why did I do that? Because it cannot be the word and. I cannot be at the same time at the right of 3 and at the left of -3. So here the interconnected word should be the word or. My solutions would have been x greater than 3 or x less than -3. And of course, we will generalize that. In general, absolute value of x greater than theta, where theta is a positive number, means that x is greater than theta or x is smaller than -theta. And once again, it's not about the x, but it's rather about the expression inside the absolute value. So even if we had that absolute value of an expression greater than something positive, we would still have taken that this expression is greater than that theta, or this expression would have been less than -theta. Let's work two examples together. Example, absolute value of x greater than 10. Obviously, we just apply the rule x greater than 10 or x less than -10. Of course, remember that we should present all that on a number line. 10 would have been here. Since we don't want that to be equal, the circle would be empty. 10 to the right means this. -10 to the left would have meant this. This is the visualization of my solutions. And finally, 3x plus 1 greater than 6 would have meant 3x plus 1 greater than, let's make that greater or equal than 6, or 3x plus 1 smaller or equal than negative 6. So 3x greater or equal than 5, which means x greater or equal than 5/3, or 3x smaller or equal than negative 7, which means x smaller or equal than minus 7/3. And let's present these on a number line. 5/3 would have been, let's say, somewhere here. It's greater or equal, so the equal will make us to shade the circle. Greater would mean from here to the right. Negative 7/3 could be somewhere here. I say that because it's equal as well. So it's towards that direction. And that would be all. Remember that we only have these cases. X, absolute value of something, of an expression being smaller than a positive, means that expression x or whatever is smaller than theta, or x is, and the word here would have been and x greater than negative theta. Absolute value of x less than something negative? Never. That can never happen. On the other hand, absolute value of x greater than something positive would have meant that x is greater than theta or x is less than negative theta. And finally, if someone had asked when an absolute value of x is greater than something negative, what would we say in this case? Always. Absolute value, we need always to keep using theory. Absolute value stands for distance. Distance is by default greater or equal than 0. So when you are asking me when an absolute value is greater than something negative, you are practically asking me when distance is greater than negative. So when something which is greater or equal than 0 is greater than negative, which the answer that I will give to you is always. Always means for all numbers. That's all. Read carefully, watch carefully this video. If, however, you face any difficulties, you have any concerns, anything you want to discuss, please feel free, feel confident to share your thoughts and leave your comment below the video. As always, thank you for your time.